We are gonna do just a little bit review for your test on Friday. So I'm just gonna call this square root review. If you haven't watched the previous two videos, this might not super make sense, so you probably need to rewatch those videos. All right, so we've been talking a lot about perfect square numbers and perfect square variables. So we're just gonna make a small little list here of perfect squares. Okay, so we have 1, 4, 9, 16, 25, 36, 49, 64, and you could keep going for a long time. If you're unsure where I'm getting those, 1 squared is 1, 2 squared is 4, 3 squared is 9, and you'll notice 1, 4, 9, that's the first of our list. So this is 4 squared, 5 squared, 6 squared, 7 squared, etc. Plenty more perfect squares, I just don't have time to write a million numbers. But we can also square variables. So we end up getting answers like x squared, x to the 4th, x to the 6th, x to the 8th, x to the 10th. Basically, as long as the variable is raised to an even number, it's a perfect square. So let me prove that to you. If you had x and you square it, you get x squared. If you take x squared and you square that, you get x to the 4th. X cubed, if we square that, you get x to the 6th because you're just multiplying these powers. It's called power rule. X to the 4th squared is x to the 8th, and you'll notice that all of these exponents are even numbers. Okay, so we're gonna do just 4 quick problems, just work, and then we're gonna do maybe 3 problems where you have to explain, because that's gonna be your test. You have to explain, not just simplify. All right, starting off, here's number 1. Number 1 is the square root of 28. 28 is not a perfect square number. So what I'm gonna start checking is it divisible by any of these perfect squares? So it's definitely not gonna be divisible by 36 and above. Those numbers are too big. 28 divided by 25, decimal, don't want it. 28 divided by 16, decimal. 28 divided by 9, decimal. 28 divided by 4 works. 28 divided by 4 is 7. 4 times 7 is 28. So the square root of 28 can be rewritten as the square root of 4 times the square root of 7. So I haven't changed anything here. I've just changed how it's written, but it's the same amount. Why are we doing this? Well, the whole point is to simplify. So what I mean by simplify is this right here, square root of 4. 4 is a perfect square number, meaning when I take the square root of it, I'm gonna get a whole number. Square root of 4 is 2. Square root of 7 can't be simplified further because it's not divisible by any of these perfect square numbers. So we just drop it down and our final answer is 2 times the square root of 7. Number 2, we're going to take the square root of 50x squared. All right, so I'm going to deal with just the number part right now, 50. 50 is not a perfect square number, so we have to break it apart just like we broke up this 28. 50 is in fact divisible by 25, which is a perfect square. 25 times 2 makes 50. So I'm going to rewrite the square root of 50 as the square root of 25 times the square root of 2. And then I'm going to look at my variable term. X is raised to the 2nd power, and that 2 is an even number, so it's definitely a perfect square. If it's a perfect square, I'm just going to drop it down in its own radical for now. Next, I'm going to simplify any of the square roots of perfect squares. The square root of 25 is 5. The square root of 2 cannot be simplified. I can't divide it by any of these, so I'm just going to drop it down. And the square root of x squared is just x. My final answer. I multiply all this up. So I'm going to multiply the stuff that doesn't have a radical, 5 times x, and I'm going to bring it out front. And then anything inside a radical gets dropped down at the end. And my final answer is 5x times the square root of 2. All right, let's do 2 more of these quick problems. Let's do square root of x to the 12th times y cubed. All right, so if these are not perfect squares, we have to break them apart. But x to the 12th is in fact a perfect square because it's raised to an even number. So I'm just gonna drop that down as is. But y cubed, 3, is an odd number. So I'm gonna have to break it apart. So here's what I do. I lower this number by 1, so that'd be y squared. And I think to myself, y squared times y is y cubed. So then I just take the root of both of those. So square root of y squared and the square root of y. Next, I'm gonna simplify any of the perfect squares that I can. So I see the square root of x to the 12th ends up being x to the 6th. Square root of y squared is just y. And I drop down the radical of y because it can't be simplified. My final answer, I kind of shove everything together. So out front you have x to the 6th y times the square root of y. Number 4, let's do square root of 64, a squared b to the 7th. Okay, so we kind of have like 3 little things in here. Square root of 64 times the square root of a squared times the square root of b to the 7th. So square root of 64, 64, yay, is a perfect square. So I'm just gonna drop it down on its own right now. A squared, a to the 2nd power, that 2 is an even number, so it's good to go. I'm just gonna drop it down in its own radical. But b to the 7th, 7 is an odd number, so I'm gonna have to break this apart. So like I said, what I do is I just lower that power by 1, and I'm gonna do b to the 6th times b. So square root of b to the 6th times the square root of b. That is equivalent to square root of b to the 7th. Now you're going to simplify all of the square roots of perfect squares. So the square root of 64 is 8. The square root of a squared is a. The square root of b to the 6th is b to the 3rd power. And the square root of b cannot be simplified any further, which means I have to keep it under the radical. Now I multiply all of the stuff that's not in a radical. So these 3, 8 times b cubed is just 8ab cubed, and then times the square root of b. Okay, so this we gotta know how to do. But guess what? Your test, you're not just gonna have easy peasy problems like this, because honestly, I'm seeing that a third of you are probably cheating. Sorry to say that, I'm just trying to be honest with you. So for you to prove mastery of this on your test, you're gonna have to explain in words, you're gonna have to type. And this little radical symbol, you can't really do that. It doesn't allow you to put that symbol in when you're typing something, which is crummy, I know. So you're just gonna write the word square root or radical, whatever's easiest for you. But I'm gonna kind of show you what's on your test, so definitely be paying attention to this. So there are 2 questions on your test. There's actually 4 total, but 2 of them are like this. It asks you, can the following radicals be simplified? And then obviously I have something that says like explain, or if they can, explain why. If they cannot, explain why not. Something like that. But bottom line is you gotta explain your answer here. Okay, so we'll call this number 5. Number 5, square root of 14. So question was, can this radical be simplified? So this is a yes or no question, but you have to back up what you have to justify your answer. So the only way I can simplify a radical is if I can divide it by one of the perfect squares. So kind of the structure to your answer would be yes, because it's divisible by the perfect square of 9 or 36 or 64, whatever. Well, if it can't divide by any of these, then you would say no, because it's not divisible by any of the perfect squares, okay? So we're looking at square root of 14. So I'm gonna block out the numbers higher than that. You could take a calculator and you could do 14 divided by 9, decimal. 14 divided by 4, decimal. 14 divided by 1 isn't cool because it just ends up as 14. So the answer to this would be no, comma. 14 is not divisible by any of the perfect square numbers except 1. And then you can follow up the statement by saying the square root of 14. And remember, on your test, you're going to have to type that. The square root of 14 is already simplified. So this is already simplified, okay? All right, so I said yes or no, and I justified it, whether it's divisible by a perfect square or not divisible by a perfect square. So here's number 12, and feel free to pause it if that was too quick. Next step, we're gonna look at square root of 12. So I'm either gonna say yes because it's divisible by a perfect square of blah, 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 or I'm gonna say no because it's not divisible by a perfect square. So 12, once again, I'm gonna cross out the numbers higher than it. 12 divided by 9, decimal. 12 divided by 4 is 3, okay? So since it can divide by a perfect square, then the answer is yes, we can simplify it. So we would say something like, yes, 12 is divisible. Oops, whoa. 12 is divisible by 4, which is a perfect square number. So notice that that vocabulary is in both of my statements, and it needs to be. That's your justification. But we're going to go further than that. Since it is divisible, since it can be simplified, then let's go ahead and simplify it. So we would type the square root of 12, but for my notes, I'm just going to go like this. The square root of 12 can be written as the square root of 4 times the square root of 3, which simplifies to 2, and then square root of 4 is 2, square root of 3 can't do anything, so final answer is 2 root 3. So that's how you answer those two questions, okay? And you can kind of use my same format here. You're just gonna have to kind of fill in the blanks. All right, and so those are the first type of questions you'll see on your test. Here's the next little chunk. And your test is gonna have 2 of these, but for your notes right now, I'm just gonna do 1. So you're gonna have to explain, like fully in-depth explain how to simplify the square root of, and let's do 75x to the 7th. Okay. So fully explain using words. We're not being cryptic. We're not going on to Google and typing some random vocabulary that you don't understand. I'm really hating to see how many of you are like going online and just kind of cheating. I need to know that you know how to do this. So you don't have to use the same structure as me. I just need to see how you're thinking about it. So I'm going to start with the number 75. 75 is divisible by the perfect square number And then look for it. 75 is divisible by 25. Okay, so that's just a statement right now. The reason why I'm telling myself this is now I can rewrite it. You can rewrite the square root of 75. So online you would have to type it, the square root of 75. You can rewrite the square root of 75 as the square root of 25 times the square root of 3. 25 times 3 is 75. Okay, so we've broken that apart. Next, I'm going to talk about if I need to break this apart, x to the 7th. Square root of x to the 7th, x is raised to an odd power. We want an even power. So x to the 7th is the same as x to the 6th times x. So you might say something like, next, the square root of x to the 7th will be written as square root of x to the 6th, and remember you're typing all that, the square root of x to the 6th times the square root of x. Okay, so all of this is just we're breaking it down into a perfect square times not a perfect square. Perfect square times not a perfect square. So your next step is to simplify the square roots of perfect squares. Now we can simplify the square root of 25 because it equals 5. And the other thing you can simplify is the square root of x to the 7th. And the square root of, x to the 6th. Square root of x to the 6th, which equals x to the 3rd. Okay? Radical 3 and radical x are going to be left in the radicals. So you could say that here. Radical 3 and radical x are left inside the radicals. Now, multiply what's left. So you had, what did we had? We had 5 times x to the 3rd times the square root of 3 times the square root of x, which equals 5 times x to the 3rd times the square root of, and then you get to combine these two together in the same radical. 5x cubed times square root of 3x. And that's your final answer, okay? So this isn't the best grammar possible. I didn't use crazy words like what you guys have been copying online, like reduce the index of the whatever. I'm like, what? Just tell me how you're breaking it apart, what you're breaking it apart into. You simplify the perfect squares and you get this, okay? Should be doable. So that is what you can expect for your test. 2 of these types of questions and 2 of these full explanations. All right, good luck. Thanks for working hard on this, guys.